Think about how word2vec learns. It slides a little window across the text, peeking at a few words at a time, and never really steps back to see the whole picture. But your entire corpus holds a mountain of statistics about which words tend to hang out together. So why learn from tiny snippets when you could use all of it at once? That's the exact question GloVe set out to answer. Its name stands for global vectors, and that word, global, is the whole point. Let's see how it works. So how do you turn a whole corpus of statistics into vectors? Let's walk the recipe one step at a time. Start by scanning the entire corpus and counting. For every word, you tally how often each other word shows up nearby, within a small window. A word like cat gets counted against the sat and mat again and again until you know exactly who keeps company with whom across all of your text. Those tallies fill an enormous grid, the global co-occurrence matrix. Rows are words, columns are words, and each entry says how often that pair appeared together across the whole corpus. Here's the crucial insight. It isn't the raw counts that carry meaning, it's the ratios. How often ice shows up with solid versus with gas tells you what ice actually is. Now learn a vector for every word, tuned so that the dot product of two word vectors matches the logarithm of how often those words co-occur. A weighting function keeps the fits sensible, so ultra-common pairs don't drown everything out and ultra-rare ones don't add pure noise. Essentially, you're factorizing that giant matrix into compact vectors. Finally, those trained vectors are your embeddings, and they arrive with a lovely bonus. Because they were fit to global ratios, they show the same clean analogy behavior as word2vec, king minus man plus woman landing near queen, while also soaking up corpus-wide statistics that a purely local method might miss. So how is this really different from word2vec? Here's the contrast, side by side. The older approach works one window at a time. Word2vec slides across the text and learns from each little local context in isolation. Strip it down, and three ideas define GloVe. It factorizes a global co-occurrence matrix. First, count how often every pair of words appears together across the whole corpus. Then learn vectors whose dot products match the log of those counts. It's really matrix factorization dressed up as word embedding. Its secret is ratios. Raw co-occurrence counts are noisy, but the ratio of how often two words each appear with a third word reveals real relationships. Comparing ice and steam against solid and gas neatly separates their meanings, and GloVe is built to capture exactly that structure. It blends both traditions. GloVe fuses the global statistics of old count-based methods with a linear, analogy-friendly structure of prediction-based ones like word2vec, and often matches or beats it on benchmarks. Like word2vec, though, GloVe produces static vectors, one per word, later fixed by contextual models. All right, let's lock in what matters. GloVe, short for global vectors, learns word embeddings by factorizing a global co-occurrence matrix built from the whole corpus at once, rather than from local windows. It first counts how often words appear near each other across all of your text, then learns vectors whose dot products match the logarithm of those co-occurrence counts. Its key insight from Pennington, Socher, and Manning is that ratios of co-occurrence encode meaning, blending count-based statistics with the analogy structure of prediction-based methods. Much like its predecessor, GloVe produces static vectors, one per word, and its pre-trained downloads became a staple of NLP projects before contextual models arrived. If you enjoy watching machine learning ideas click in a place like this, there's a whole library of them waiting at Standarity.com. See you over there.